Okay, so once again, very good afternoon all. In the last lecture, we have started the problems based on the SFD and BMD for the overhanging beam. And in the previous lecture, we have discussed about the sign conventions which we have to use to draw the SFD and BMD for the overhanging beam. In addition to that, we have discussed what is the basic difference between the simply supported beam and the overhanging beam. What is the common things and what are the different things that also we have discussed in the previous lecture. So common things are the beam is both simply supported and the overhanging beam are subjected to only two supports. And then what is the different things? Where supports are provided. If the supports are provided at the end points, then that will be the simply supported. But if the supports are provided are not at the end points, maybe your beam is extended beyond the support from one side or from another side, that will be the overhanging beam. Overhanging beam. So otherwise, whatever the procedure we have implemented that is used to solve the SFD and BFD for the simply supported, same procedure without any change we are using for the overhanging beam. And by using that procedure in the previous lecture, we have solved one numerical. So today also one more numerical we will solve based on the overhanging beam, and then we will move to the next step. Okay, so now I will give the figure directly how it is subjected to the loading, because I have told so maximum times if there is a overhanging beam, so 90 to 95% chances where the figure is given to you, because when there is overhanging beam, so sometimes it is very difficult to give the statement. So instead of giving the statement directly, the figure will be given to you, and from that figure we have to go for your further solution. So I will draw the figure here, and you also take this figure in your notebook, and accordingly we will go for the solution. So draw this figure. So this is the overhanging beam. So this is point A, B, and here this is point C, D, and E. Okay. So here it is subjected to UDL. So this UDL is 20 kilonewton per meter. This point load value is given 105 kilonewton. Second UDL is given 10 kilonewton per meter. And these are the some important dimensions they have given. So first AB distance is 1 meter. Then this BC distance is given 2 meter. This is 1.5 meter, and last one is also 1 meter. So this is the figure given to you, that is overhanging beam. Why it is called as overhanging? Because if you go through the supports, so the supports are provided at point B. So this is point B, and the one more support is provided at point D. But at point B and at point D, again the beam is extended from their end portions. So beyond the supports, the beam is extended, that is from point B, it is extended to the left side, and from point D also, it is extended to the right side. And as per our definitions, if the beam is extended beyond the support either from one side or either from both sides, so that particular beam will be called as a overhanging beam. So now this is the figure in front of you. So what is that figure indicates? This is the overhanging beam which is subjected to the UDL. So one UDL is applied at the portion AB, that is at the left side. One more UDL is applied at the right side, that is portion D to E. And at point C, it is subjected to one point load, that is 105 kilonewton. And we have to draw the SFD and BMD for this particular overhanging beam. Okay, so this is the problem given to you. So one by one we will follow the procedure. So first requirement is that we have to take their all the projection lines below as it is as per their original points. So this is our projection lines we have taken at the bottom side. Now, what is our second requirement? What we have to do here?
UDL convert into point load.
Yes. Wherever UDL and UVLs are given, the first requirement is that you have to convert that UDL into point loads. Okay. So these are the points. That is point A. This is point B. At point C, it is subjected to point load of 105 kilonewton. That is point C. Then this is point D. This is point E. Okay. So B and D, there is a supports. So here I will represent reaction RB. At D points, once again, this is the reaction RD, and then distances. So this is 2 meter, this is 1.5 meter. So AB distance and DE distance we will represent afterwards. Now, if you think about the left side of the beam, there is a portion AB, and that AB portion having length 1 meter, and it is subjected to the UDL of 20 kilonewton per meter, and we are having the formula. So whenever we are converting to the UDL into the point load, we are having the formula W into L. So what I will do, that point load I will represent here by the dotted line. This is the dotted line. So we are having the formula W into L. So what is the value of W? 20 into
20.
1. So what is the point load value?
20.
20 kilonewton.
Kilonewton. Okay. Then it will be acts at the center. It will be acts at the center of the AB. That means L by 2. Suppose this is point P. So what is the AP distance?
0.5.
0.5 meter and 0.5 meter. Okay. Similarly, at the right side of the portion, that is portion DE, it is also subjected to the UDL, but that UDL value is different. It is equal to 10 kilonewton per meter, and it is spread over the length of 1 meter. So again, that UDL also we need to convert into the point load. So this is the dotted point load. We are having the formula W into L. So W value is 10 into 1. So what is the UDL converted into the point load is 10 kilonewton. Okay. It is also acts at the center of the DE distance, that is L by 2. So 0.5 meter and 0.5 meter. So this is your loading diagram. So many of the UDLs are given, so we need to convert that UDL into the point load because it becomes very simple. And so that you will get the two loading diagrams. One is with UDL and another is UDL converted into the point loads. And now if you look at to the figure, so in this particular figure, total 3 forces which are moving in the downward direction. That is, one is point load which is applied at point C, and remaining 2 loads are UDL converted into the point load that are also moving in the downward direction, and 2 reactions, that is reaction RB and reaction RD, they are moving in the upward direction. So this is our original loading diagram. Now one by one we'll go for the solution. So first requirement is that reaction calculation, that is summation of VFV is equal to 0. Now how many forces are present? Total vertical forces on the loading on the beam. How many total
5.
number of forces? 5. Okay. How it is 5? The 3 forces, that is one point load of 105 kilonewton, another UDL which is converted into the point load, that is 20 kilonewton, and second UDL which is converted into the point load 10 kilonewton. So these are the 3 forces which are moving in the downward direction, and these reactions RB and reaction RD, this is also one of the force, but instead of it is called as a point load, it is called as a reaction. That means 3 forces moving in the downward direction, 2 forces moving in the upward direction, total 5 forces are present. So as per our sign convention, upward force is positive, downward force is negative. So start from the left side. So this minus 20, then plus RB, minus 105, plus RD, and minus 10 is equal to 0. So RB plus RD is equal to 20 plus 105 plus 10. So RB plus RD. What is the value of
135.
RB plus RD? So it becomes 125, then 135 kilonewton. Everyone has to calculate it and keep, this is the equation number 1, that is RB plus RD. Okay, now if you look at to this particular equation number 1, here two unknowns are there. RB is also unknown, RD is also unknown. Then what is our second requirement? At one reaction point we have to take moment is equal to 0. At one reaction point we have to take moment is equal to 0. Now in this particular figure, one reaction is present at point B, another reaction is present at point D, and I have told always try to take the reaction or summation of M is equal to 0 at the left side. आतापर्यंतच्या प्रॉब्लेम मध्ये आपल्याला ह्या पॉइंट ए ला समेशन ऑफ एम आपण 0 करायचो कारण तुमची रिएक्शन ह्या पॉइंट ए ला असायची. But now instead of giving this reaction at particular point A, it is shifted to the point B. So what we have to do at one reaction point, moment is equal to 0. So summation of MB is equal to 0. But while taking this particular summation of MB, we need to consider all the forces on the figure. We need to consider all the forces in the figure which are present at the left side, which are present at the right side. ह्या ठिकाणी आपल्याला we have to start the SF from the left side, we have to start from the BMs, we have to start the bending moment from the left side. That concept is not applicable here for summation of BMB calculation. Whenever we are taking this moment at one reaction point is equal to 0, so we have to resolve all the forces towards point B. It may be at left side, it may be at right side. Okay, initially we'll take the forces from the left side and afterwards we'll take the forces from the right side. Now tell me, how many forces are present at the left side of the point B?
1.
One force, which is
UDL.
UDL. Okay, that UDL we have converted into the point load, that is point P. आणि इकडचे UDL आपण point load मध्ये convert केला त्याला आपण point Q मध्ये. Okay, now resolve this particular UDL point or UDL point load towards point B. Tell me whether it is rotating in anti-clockwise or clockwise direction.
Anti-clockwise.
Anti-clockwise.
Anti-clockwise. बघा हा point P इथं आहे, तो जर आपण point B ला resolve केला तर it is rotating anti-clockwise. Therefore minus 20 into distance
0.5.
0.5 correct. Then point B तर आपल्याला रिएक्शन घेताच येत नाही कारण तिथं आपण 0 कन्सिडर केले. Then next, how many forces are present to the right side of the point B including reaction? 3 forces. See 105 kilonewton force, रिएक्शन RD आणि तिसरा म्हणजे हा UDL, ज्या UDL चा आपण पॉइंट लोड मध्ये कन्वर्ट करून आपल्याला त्याची 10 किलोन्यूटन व्हॅल्यू मिळालेली आहे. Now start one by one. Resolve this point load which is applied at point C towards point B. It is rotating clockwise or anti-clockwise?
Clockwise.
Clockwise. 105 kilonewton force is rotating clockwise, therefore positive. So in bracket 105 into distance 2 meter. Okay. Then next RD. This reaction RD is rotating anti-clockwise or clockwise towards point B?
Anti-clockwise.
Anti-clockwise. So minus RD into distance between A, B and D.
3.5.
3.5.
3.5. This multiplication of distance is very, very important. And plus, now the second UDL we have converted into the point load and its value is 10 kilonewton. Okay. Now I have to resolve this particular 10 kilonewton towards point B. It is rotating clockwise or anti-clockwise? Clockwise. So I will write first magnitude 10 plus 10 into distance between B and Q. Measure करा. 2 meter plus 1.5 meter आणि राहिलेलं 0.5 meter म्हणजे किती आलं टोटल 4 is equal to 0. Now here this minus 20 into 5 plus 105 into 2 plus 10 into 4, and this minus RD into 3.5 it is present at the left side, and left side ला असणारी ती व्हॅल्यू काय आहे तुमची निगेटिव्ह आहे. ती जर मी राईट साइडला घेतली तर काय होणार आहे ती पॉझिटिव्ह. सो RD into 3.5. now tell me the RD reaction.
68.57.
68.57, correct. So everyone, are you able to calculate this reaction? What I have taken, I have resolved all the forces towards point B, and from that I have taken unknown at the right side, कारण लेफ्ट साइडला असताना तुमचा RD into 3.5 ही व्हॅल्यू कशी आहे तुमची निगेटिव्ह आहे. जर ती व्हॅल्यू मी राईट साइडला घेतली तर ती काय होणार तुमची पॉझिटिव्ह होणार. मग लेफ्ट साइडला काय झालं तुमचं फक्त -20 into 5 प्लस 105 into 2 प्लस 10 into 4 ह्या आलेल्या आन्सरला फक्त ह्या 3.5 ने जर डिवाइड केलं तर यू विल गेट 68.57 kilonewton. Everyone have got the answer? What is your answer?
68.57.
68.57. What about others? Have you got this answer or not? Try
Yes,
to
sir.
represent your answers in the chat box, so I also clear that you have calculated and you got this answer. 68.57. This is the reaction RD. Only we have to go for the multiplication. Simple. We have to go for the multiplication, and त्या आलेल्या multiplication addition करून फक्त त्याला 3.5 ने, कारण RD into 3.5 आहे, ते 3.5 पण आपल्याला लेफ्ट साइडला डिवाइड करावं लागेल. Okay, 68.57 kilonewton. Now from equation 1 we are having, so from equation 1 RB plus RD is equal to 135 kilonewton. Okay, so RB plus 68.57 is equal to 135. Therefore, what is RB value?
66.
135.63.
66.43.
66.43 kilonewton. So this is the reaction RB. So you have to represent that reaction value on the figure also, because here it is important. So RB is equal to 66.43 and RD is equal to 68.57. So this is your reaction calculation. Reaction calculation. Reaction RB and reaction RD. Have you calculated? Have you got the reactions, all of you? Yes, everyone, have you calculated the reactions?
Yes, sir.
Yes.
Others, boys, students, have you calculated?
Yes, sir.
Okay, so now the reactions are calculated. We'll go for the second important calculation, that is SF calculation. SF calculation. So upward force is positive, downward force is negative. Now one by one, start from the left side of the beam. SF at A. So at point A, whether we have to take without load and with load condition?
No.
No. Yes, what about others? Whether we need to take the without load and with load condition at point A?
No, sir.
No, because at point A, no any reaction, no any point load. We are taking the without load and with load condition at those point where that point is either subjected to point load or it is either subjected to the reaction. But at point A, there is no any reaction, there is no any point load. So directly I will take SF at point A. So what will be the value?
0.
0
Zero.
kilonewton, because we have started the SF calculation from the left side. Point A च्या left side ला एकही portion आहे, that's why it is equal to 0 kilonewton. Okay, then SF at B. Now what we have to take at point B?
Without load.
Without load condition, because at point B reaction is present, therefore SF at point B विदाउट लोड म्हणजे पॉइंट बी चा लोड न कन्सिडर करता पॉइंट बी च्या लेफ्ट साइड ला हाऊ मेनी फोर्सेस आर प्रेझेंट?
1.
ओनली वन, दॅट इज 1 UDL. आणि त्या UDL आपण पॉइंट लोड मध्ये कन्वर्ट करून आपल्याला त्याची व्हॅल्यू मिळालेली आहे. म्हणजे काय व्हॅल्यू आहे सांगा आपली?
-20
kilonewton.
kilonewton.
That 20 is moving in the downward direction, therefore that value we have to write down negative, that is 20 kilonewton. Then SF at B with load. With load means we have to consider the left side forces plus load at that point. मग left side चा forces आहे -20. ओके, आणि रिएक्शन चा फोर्स किती आहे आपला?
66.43.
66.43, and it is moving in upward direction, therefore positive. Then tell me this calculation, -20 plus 66.43.
46.43.
46.43 kilonewton. Okay, now point B is over. Now point C. SF at C. Again there is a without load condition, because at point C it is subjected to the point load. Now tell me how many forces are present at the left side of the point C without load? 2. कुठले कुठले? एक म्हणजे UDL आणि दुसरं म्हणजे रिएक्शन. मग UDL चा पॉइंट लोड खाली चाललाय, रिएक्शन वर चाललाय, म्हणजे परत तेच, दॅट इज -20 प्लस 66.43 which is equal to 46.43 kilonewton. Then next, SF at C with load means -20 plus 66.43, and now we have to consider the with point load means load applied at point C, that is 105. It is positive or negative?
Negative.
It is moving in downward, therefore it is -105. You tell me this answer.
-58.57.
Minus
58.57.
58.57 kilonewton. Okay, now next point. What is next point? SF at point B. SF at D. Again there is a without load condition, because at point D reaction is there. Now tell me how many forces are at the left side of the point D?
3.
3 forces. एक UDL, एक रिएक्शन आणि एक पॉइंट लोड. मग पहिल्यांदा UDL घ्या -20, परत रिएक्शन B घ्या, किती आहे? 66.43 -105, म्हणजे परत तेच आन्सर येणार काय? -58.57 kilonewton. Then SF at D with load. Okay, -58.57 तर आहेच. It is present at the left side, and by considering the force of point D, it is moving in upward direction, therefore plus 68.57. What is this answer?
10.
10.
10 kilonewton. Okay, then SF at, what is the next point after point D?
E.
E. Don't take the SF at point Q. तो क्यू म्हणजे आपण काय दाखवलाय फक्त ह्या युडीएलचा पॉईंट लोड मध्ये कन्वर्ट करून त्याची व्हॅल्यू आपल्याला 10 किलो न्यूटन ह्या फिगरवर इंडिकेट करायची आहे. म्हणून तो पॉईंट क्यू आपण तिथं दाखवलाय आणि तो डॉटेड लाईनला दाखवलाय. सो आफ्टर पॉईंट डी डायरेक्टली टेक SF at point E, and at point E no reaction, no point load, so directly I will take SF at point E. Now number of forces present at the left side of the point E, किती forces आहेत सांगा?
5.
5.
5. One UDL, second reaction RB, third point load 105 किलोन्यूटन, त्याच्यानंतर रिएक्शन RD आणि त्याच पॉइंट E च्या लेफ्ट साइडला परत हे 1 मीटरचं युडीएल पण आहे, त्याचं पॉइंट लोड मध्ये कन्वर्ट करून आपण 10 किलोन्यूटन लिहायचं. सो 1 by 1 -20 प्लस 66.43 -105 प्लस 68.57 and -10 kilonewton. किती येते आन्सर सांगा?
0.
0.
0 kilonewton. Means your start of the SF calculation and end of the SF calculation, it is coming equal to 0. Means whatever the middle calculation you have made, it is 100% correct. So what care you have to take while calculating the shear force at any particular point? Try to measure the number of forces which are present at the left side, and ते forces measure करताना take all the reactions, take all the points load and take the UDL also. फक्त त्या UDL आपण point load मध्ये केलेलं असते, conversion केलेलं असते. That also we have to consider at the left side. मग without load घेताना फक्त left side ची घ्यायची आणि with load घेताना लेफ्ट साइड प्लस त्या पॉइंटवर अप्लाय झालेला पॉइंट लोडचा इफेक्ट पण आपल्याला विथ लोड कंडिशन मध्ये कन्सिडर करावा लागतो. ओके, सो दिस इज द SF calculation. Now immediately go for the diagram. So this is point A, B, C, D and E. Now tell me one by one. SF at point A 0, SF at point B, SF
-20.
at point B
-2.
मायनस, त्यामुळे पहिल्यांदाच मायनस म्हणजे दिस इज बिलो द झिरो लाईन -20 किलोन्यूटन. SF at point B ही विदाउट लोड झाली, विथ लोड किती आले?
46.40.
इट इज
46.43.
पॉझिटिव्ह. देअरफॉर ह्या निगेटिव्ह वरून त्याच लाईनवर तुमचं कुठं जाणार आहे? पॉझिटिव्ह रिजन मध्ये जाणार आहे. 46.43. SF at point C without load
46.43.
तेवढीच राहिलेली आहे, 46.43. SF at point C with load
-58.
-58.57.
-50. ऑलरेडी आपण 20 चा पॉईंट इथं रिप्रेझेंट केला, म्हणजे त्याच्या थोडा अजून खाली आपल्याला -58.57. SF at point D without load
-58.57.
-58.57. SF at point D with load
10.
10.
म्हणजे 46 थोडंफार इथं कुठं दाखवलं पाहिजे, 10 किलो न्यूटन. SF at point E without or at point E
0.
0.
directly it is equal to 0. Now tell me how to draw AB distance.
Parabolic.
This is SFD. This is SFD. How to draw the AB distance if there is a UDL on the loading diagram? Yes,
Inclined line.
Inclined line.
If parabolic curve we have to represent in the bending moment diagram, but for the UDL ज्या ठिकाणी आपण x distance काढले, ते x distance आपल्याला कसं काढता आलंय? There is a symmetrical triangle rule, आणि symmetrical triangle आपल्याला कशामध्ये मिळतोय? SFD मध्ये मिळतोय. Why? Because that beam is subjected to the UDL. मग UDL जर आपल्याला SFD मध्ये रिप्रेझेंट करायचं असेल तर it must be inclined line. So first this is inclined line, then this vertical line, कारण बी वर 2 पॉइंट मिळालेले आहेत, त्यामुळे पॉझिटिव्ह कडून निगेटिव्ह कडून परत तुमची डायग्राम पॉझिटिव्हला जाणार आहे. देन B2C डिस्टन्स हॉरिझॉन्टल, परत पॉझिटिव्ह कडून तुमची डायग्राम निगेटिव्ह कडे. परत C to D डिस्टन्स हॉरिझॉन्टल लाईन. परत ह्या D पासून युअर डायग्राम विल मूव्ह इन द पॉझिटिव्ह रिजन. अँड हाऊ टू ड्रॉ द DE डिस्टन्स वन्स अगेन?
Incline.
D to E.
Inclined line.
Again there is a inclined line. Wherever the point loads are provided in that portion, there is only horizontal lines and inclined lines. If you see the SFD, if there is a point load in that portion, there is only horizontal lines and inclined lines. But if any portion is subjected to the UDL, in that particular portion there is an inclined line. बघा, AB portion मध्ये आपलं UDL आहे, त्यामुळे AB portion मध्ये you will get the inclined line. Similarly, in the portion D to E, again there is a UDL, therefore you will get the inclined line. But from point B to C and from point C to D, म्हणजे B ला पण एक point load आहे, C ला पण एक point load आहे आणि D ला पण एक point load आहे. Point load म्हणजे reaction line. But if you see the portion of SFD from point B to D, there is only vertical line and horizontal line. बघा, पॉइंट बी पासून सी कडे गेला तर तुम्हाला दोन वर्टिकल लाईन मिळते, एक हॉरिझॉन्टल लाईन. इफ यू गो फ्रॉम पॉइंट सी टू डी, अगेन देयर इज अ वर्टिकल लाईन अँड द हॉरिझॉन्टल. दॅट मीन्स नो एनी inclined line you will get in that portion where the beam is subjected to only point load. If it is subjected to the UDL 101%, it must be inclined line in your ESM. So this is related to the shear force diagram for this particular overhanging beam. So if you see this particular figure, sometimes your SFD positive region, sometimes your SFD is in negative region. So here you will get the point of contrast shear at the 3 points. Here you will get the point of contrast shear at the 3 points. Which are those?
B, C, and D.
Yes, which are those? Point B, point B, point C, and point D. Because if you see the point B, your SF, it changes from negative to positive. If you see the point C, your SF, it changes from positive to negative. And if you see the point D, again your SF, it changes from negative to positive. That means at this particular 3 points, there is a changes in SF calculation, and accordingly your SF diagram is also changes from negative to positive and the positive to negative. And our point of contrast shear definition tells that it is the point at which SF changes its sign from positive to negative and vice versa. आणि या तिन्ही पॉइंट आपले डायग्राम चेंज झाले, त्यामुळे आपण तिन्ही पॉइंटला पॉइंट ऑफ कॉन्ट्रास्ट शेअर म्हणू शकतो. बट whether that point are going to satisfy our second definition or not, because at point B, at point C, and at point D, shear force value is equal to 0. या तिन्ही पॉइंटला shear force ची व्हॅल्यू काय झाले? 0 आलेलं आहे. But at the same point, whether our bending moment value is maximum or not, that we have to check during the BM calculation. So for that purpose, we have to go for the BM calculation first, and after drawing the diagrams of BMD, then we have to check whether our second definition is satisfying or not. That means at point B, C, D, shear force is 0, and त्याच पॉइंटला बेंडिंग मोमेंट डायग्राम मध्ये बेंडिंग मोमेंट मॅक्सिमम येते का नाही, that also we need to check. जर ते येत असतील तर तिन्ही पॉइंटला आपण पॉइंट ऑफ कॉन्ट्रास्ट शेअर म्हणू शकतो. पण त्या तिन्ही पैकी समजा एकाच पॉइंटला जर तुमचा shear force value 0 आणि बेंडिंग मोमेंट व्हॅल्यू मॅक्सिमम येत असेल, तर only at the single point is called as a point of contrast shear. So this is the conditions which we have to satisfy during the BM calculation, and it will get observed when we will draw the BMD. So we'll move to the next, that is BM calculation. So whether my screen is visible?
Yes, sir.
So I think it will not be visible. I think now it is not visible. Or is it visible? So I think there
No,
is
sir.
due to electricity problem. So I am unable to share the screen. So we'll wait for the. Okay, no problem. Meanwhile, the electricity will come. So we will solve the numerical. You just put the title BM calculation. We will discuss through this BM calculation. Put the title. You keep your mic on and try to give the answers to me. I will verify your answers also. BM calculation. Now the BM calculation also we have to start from the left side. BM calculation also we have to start from the left side. So first BM at A. What will be the value? BM at point A.
0.
0.
Okay. BM at point A is equal to 0 because I have told at the end points of the beam always your bending moment value is equal to 0. And now in this particular figure, one end point is present at point A and another end point is present at point E. That's why bending moment at point A is equal to 0. Now, next bending moment at point B. Write down. BM at B. BM at B. Now tell me, how many forces are present at the left side? Once again,
1.
only one force. कुठला तर आपण UDLचा point load मध्ये convert केलेला आहे. Okay. If I will resolve this particular force towards point B, it is rotating
Anti-clockwise.
What will be the value? Bending moment at point B is equal to, tell me the total step, minus 20 into
0.5.
0.5.
So what will be your answer? You send your answers in the chat box. So I will verify. Minus 20 into 0.5.
Minus 10.
Minus 10.
Minus 10 kilonewton meter. Bending moment at point B is equal to minus 20 into 0.5 minus 10 kilonewton meter. Full stop. Next, yes, minus 10 kilonewton meter, correct. Now next, bending moment at C. Bending moment at point C. Number of forces present at the left side, how many?
2.
2.
Forces. एक म्हणजे तुमचं UDL आणि दुसरं म्हणजे रिएक्शन RB. मग UDL चा point load, it is rotated in anti-clockwise direction. Then first take it minus 20 into distance. त्या point P आणि C मधलं distance किती आहे सांगा?
2.5. 2.5.
Yes, minus 20 into 2.5. कारण त्या point P आणि C मधलं distance किती आहे? 2.5. So minus 20 to 2.5. Now reaction RB, it is rotating clockwise. Therefore, plus RB into distance between B to C.
2.
2.
2.
And go for the calculation and tell me your answer. What will be BM at point C? Minus 20 into 2.5 plus 66.43 into 2.
82.86.
Okay, 82.86. What about others? Have got your answer? 82.86 bending moment at point C. You represent your answers in the chat box. 82.86 bending moment at point C. C च्या लेफ्ट साइडला दोन फोर्सेस आहेत. Bending moment at point C. Yes, 82.86. 82.86, correct. Now, bending moment at point D. After point C, bending moment at point D. D च्या left side ला. How many forces? Total number of forces present at the left side of the point D?
3.
3.
3 forces. Out of that, one UDL converted into point load. another reaction RB, and third one 105 kilonewton force which is applied at point C. So start from the left side ला सगळ्यात फोर्स आहे तो म्हणजे तुमचा UDL चा पॉइंट लोड मध्ये कन्वर्ट केलेला. It is rotating anti-clockwise direction. Therefore, -20 into distance between P to D.
4.
बघा डिस्टन्स बिटवीन P to D म्हणजे कसं आहे बघा, B to C 2 मीटर, C to D 1.5 मीटर. इट बिकम्स 3.5. पण आपल्याला P पासून डिस्टन्स घ्यायचं त्यामुळे राहिलेलं 0.5 पण त्या ठिकाणी आपल्याला कन्सिडर करावं लागणार. So 0.5 plus 2 plus 1.5 it becomes 4. That is -20 into 4. Second reaction RB is rotating clockwise direction. Therefore, plus RB into distance
3.5.
3.5. Correct. Plus RB into 3.5 minus. Why minus? Because 10.5 kilonewton load is rotating anti-clockwise. Therefore, minus 105 into
1.5.
1.5 minus 10.5 into 1.5. So do the total calculation and send your answers in the chat box, or you can tell.
-4.995.
Yes, minus 4.99. So what about others? Have got the same answer? Minus 4.99. Please check your answers, or you can send your answer in the chat box. Minus 4.99. Minus 4.99. So here this calculation sometimes it is very simple, but by mistake you are taking some another distances. काही ठिकाणी आपण एक्स्ट्रा डिस्टन्स कन्सिडर करतो, काही ठिकाणी आपण मिनिमम डिस्टन्स कन्सिडर करतो, काही ठिकाणी डिस्टन्स कन्सिडर करत नाही. That's why your calculation becomes wrong. So while resolving that particular force, first of all write out the force value. Force resolve करताना काय करायचं, पहिल्यांदा force ची व्हॅल्यू लिहायची. If it is negative, put negative sign. If it is positive, put as it is, that is positive value. And then check the distance. त्या पॉइंट पासून आपल्याला कुठल्या पॉइंटला रिझॉल्व करायचंय त्यातले सगळे डिस्टन्सेस मेजर करा, and then you have to multiply by the distance to that particular point load. So like that you follow, like that procedure we have to follow. So 4.99 is correct. Now bending moment at point E, it is equal to 0 kilonewton meter. So need not required to calculate. आणि जरी तुम्ही कॅल्क्युलेट केलं, सगळे प्रोसेस रिझॉल्व केले पॉइंट ई ला, तरी पण तुमचा आन्सर 0 येणार आहे. Therefore, bending moment at point E is equal to 0 kilonewton meter. Now go for the BM diagram. So below SFD, you once again you draw the horizontal line, that is 0 line. So meanwhile, I will join from some another device. So draw the bending moment diagram. Point A, point B, point C, point D, and point E. Find the bending moment at point A is equal to 0. Then bending moment at point B minus 10 kilonewton meter. कुठे येणार तो पॉइंट, पॉझिटिव्ह रिजन मध्ये का निगेटिव्ह रिजन मध्ये? निगेटिव्ह. तिथं पॉइंट बी आले की तिथं खालच्या बाजूला पॉइंट बी ला -10 kilonewton meter. Only represent the point first. Then bending moment at point C. 82.86. कुठं जाणार आहे तो पॉइंट, पॉझिटिव्ह व निगेटिव्ह मध्ये? पॉझिटिव्ह रिजन मध्ये. मग त्या पॉइंट सी च्या बरोबर जे काय आपण प्रोजेक्शन लाईन घेतलेलं आहे त्या ठिकाणी फक्त पॉइंट एक दाखवा, त्या ठिकाणी लिहा 82.86 kilonewton meter. Then bending moment at point D. It is moving in the negative region. म्हणजे तो 10च्या थोड्या वरच्या बाजूला असेल का खालच्या बाजूला असेल? It is -4.99 म्हणजे
वरच्या.
-4.99 म्हणजे ते 10च्या थोड्या वरच्या बाजूला असेल. It is in negative region. So represent that -4.99 kilonewton meter. And bending moment at point E is equal to 0. Then join all the points. How to join? A to B distance म्हणजे 0 to -10 kilonewton meter हा पॉइंट आपण किंवा हा पोर्शन कसा जॉईन करणार आहे सांगा.
Parabolic curve.
Parabolic curve. So draw the parabolic curve there. Then from point B to C, म्हणजे -10 kilonewton meter and 82.86. How it is drawn?
Inclined line.
Inclined line. So there is no any parabolic curve कारण B to C मध्ये तुमचा UDL नाही. त्यामुळे -10 kilonewton meter पासून डायरेक्ट 82.86 पर्यंत डायरेक्टली एक इन्क्लाइन लाईन ड्रॉ करा. सिमिलरली फ्रॉम C to D म्हणजे 82.86 पासून -4.99 पर्यंत. How to join this particular distance C to D?
Inclined line.
Again there is an inclined line because from portion B to C no UDL means it should be inclined line. From C to D again no UDL means it must be inclined line. And then from point D to E
Parabolic curve.
पॅराबोलिक कर्व कारण D to E मध्ये तुमचं UDL आहे. म्हणजे बघा एसएफडी जर तुम्ही बघितले तर एबी डिस्टन्स मध्ये आपण UDLच्या ठिकाणी इन्क्लाइंड लाईन ड्रॉ केले आणि तीच बीएमडी मध्ये बघितलं तर त्या ठिकाणी पॅराबोलिक कर्व. सिमिलरली ऍट अ पोर्शन D to E एसएफडी मध्ये बघितलं तर इट इज इन्क्लाइंड लाईन. इन बीएमडी इट इज पॅराबोलिक कर्व. आणि एसएफडी मध्ये तुम्ही पोर्शन B to D बघितला म्हणजे B to C आणि C to D तर त्या ठिकाणी फक्त हॉरिझॉन्टल आणि व्हर्टिकल लाईन आहेत. पण तोच पोर्शन तुम्ही खाली बीएमडी मध्ये जर बघितला तर यू विल गेट द इन्क्लाइंड लाईन. नाउ टेल मी, already we have discussed at point B, at point C and at point D the shear force value is 0. But out of this particular 3 points, if you look at to all the B, C, D points in the bending moment diagram, at which point you will get the maximum BM?
At point C.
At which point you will get the maximum BM?
C.
At point C.
C. कारण B ला जर तुम्ही बघितलं तर त्या ठिकाणी तुमचा B चा पॉइंट हा निगेटिव्ह रिजन मध्ये गेलेला आहे. तुम्ही पॉइंट D ची व्हॅल्यू बघितली तर तो पण निगेटिव्ह रिजन मध्ये गेलेला आहे. बट इफ यू लुक ॲट टू द पॉइंट C म्हणजे C पॉइंट जर तुम्ही एसएफडी मध्ये जर बघितला तर त्या ठिकाणी तुमची पॉझिटिव्ह टू निगेटिव्ह एसएफ डायग्राम चेंज झालेले आहे आणि त्याच पॉइंटला शिअर फोर्स व्हॅल्यू पण 0 आहे. आणि तोच C पॉइंट जर तुम्ही खालच्या बाजूला बीएम मध्ये बघितला तर त्या पॉइंटला तुमची बेंडिंग मोमेंट व्हॅल्यू पण मॅक्सिमम आहे. देअरफॉर द पॉइंट C will satisfy all the conditions of point of contraction. Now आता BMD मध्ये सांगा. I will join some another device. Now in BMD from portion B to D you will get 2 points. What are those 2 points?
Point of contraflexure.
सांगा मग एक पॉइंट ऑफ कॉन्ट्राफ्लेक्चर कुठल्या पोर्शन मध्ये मिळाला आणि दुसरा पॉइंट ऑफ कॉन्ट्राफ्लेक्चर कुठल्या पोर्शन मध्ये मिळाली?
B to C and C to D.
करेक्ट. बघा तुम्ही -10 पासून 82 कडे गेलाय आणि परत 82 पासून -4.99 ला आलाय. त्या ठिकाणी B to C मध्ये तुमची लाईन क्रॉस झालेली आहे म्हणजे तिथे एक तुम्हाला नवीन पॉइंट मिळतोय आणि परत C to D मध्ये तुमची लाईन क्रॉस झालेली आहे. त्या ठिकाणी तुम्हाला नवीन पॉइंट मिळतोय आणि त्याच पॉइंटला आपण काय म्हणतोय पॉइंट ऑफ कॉन्ट्राफ्लेक्चर. व्हॉट इज द डेफिनेशन ऑफ पॉइंट ऑफ कॉन्ट्राफ्लेक्चर? It is a point at which BM changes its sign from positive to negative. म्हणजे BC पोर्शन मध्ये निगेटिव्ह कडून पॉझिटिव्ह कडे गेलेले आहे आणि CD पोर्शन मध्ये पॉझिटिव्ह कडून तुमच्या निगेटिव्ह रिजल्ट आलेले आहे. जर असे जर तुमची बेंडिंग मुवमेंट डायग्राम पॉझिटिव्ह टू निगेटिव्ह आणि निगेटिव्ह टू पॉझिटिव्ह चेंज होत असेल तर त्या पॉइंटला आपण काय म्हणतोय पॉइंट ऑफ कॉन्ट्राफ्लेक्चर. सो दिस इज आवर PMD फॉर द ओव्हरहँगिंग बीम. जस्ट वेट, I will join. Yes, am I audible?
Yes, sir.
Whether my voice is audible to all?
Yes, sir. Yes, sir.
Yes. Yes, voice is audible.
Yes, sir.
Can anybody, you can unmute from your side?
Yes, sir. Audible.
Yes, sir.
Yes, anyone? Can you unmute because your voice is
Yes,
not
sir.
audible to me?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Sir.
Okay, just wait. Now it is audible to all?
Yes, sir.
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 I don't know, your voice is not audible. Okay, no problem. I hope my voice is audible to all. Okay, so we have discussed just now about the problem. So I think it is not saved due to the electricity problem. But just I will draw that particular BMD here. So this is point A, this is point B, this is point C, this is point D, and this is point E. So like that, this is minus 10 kilonewton meter, then this is minus 82.86, then this is minus 4.99. So this AB distance you have to draw by the parabolic curve, then this is inclined line, then this is inclined line, and again this is parabolic curve. So this is your bending moment diagram. So this is in first portion in negative region, then this is positive, and this is negative region. And in between B to C, here you will get the additional 2 points, here also and here also. And these points are called as a point of contraflexure. This is called as a point of contraflexure. So why? Because at this particular point your BM changes its sign from negative to positive, and again in the next point your BM changes the sign from positive to negative. Means your first definition is satisfied, that is point of contraflexure, it is the point at which Bm changes its sign from positive to negative and vice versa. So that particular point is called as a point of contraflexure. And what is the second definition? It is the point at which bending moment is equal to 0. Now if you look at to this particular point from B to C, B to C मध्ये जो काय तुम्हाला नवीन point मिळालेला आहे, this point is present on the 0 line, means at this particular point bending moment is equal to 0. And if you look at to the next point from portion C to D, again this point is also present on the 0 line, therefore that point is also called as a point of contraflexure. So this will be your bending moment diagram for the previous overhanging beam. And we also observe that the point of contra shear where the shear force is 0 and bending moment is maximum. So second definition will be applicable at point C only. But first definition is applicable for all the 3 points, that is point B, point C and point D, because all the 3 points your SF changes its sign from positive to negative. So this will be the problem based on the overhanging beam. So now here in this particular problem, you will not get any x distance. In this particular problem, you will not get any x distance, because whatever the points you will get, it is present on the given loads or given points or given original points. Because if you look at your SFD diagram, at point B also shear force is 0, but that point you will get at point B only. At point C also you will get the shear force 0, it is also present on the point C only. At point D also you will get the shear force 0, but it is also present at point D only. So need not require to calculate the x distance, कारण तुम्हाला point of contra shear you will get at the original points only. So need not require to go for any further calculation. So this is related to the SFD and BMD for the overhanging. So what is the procedure we have followed for the simply supported beam? Same procedure we have followed for the overhanging beam. Only there is a type of beam, it will be different. So this is related to the SFD and BMD for the overhanging beam. So now everyone have understood the procedure for the overhanging, how it is to be calculated? Yes, everyone have understood? Can someone is unmute and you can say like yes, because I think your voice is again not audible to me. Can anybody?
Yes, sir.
Okay, still it is not audible.
Yes, sir.
Just I will check. Now can you unmute from your side once again?
Yes, sir.
Yes,
Yes,
sir.
sir.
नाही त्यांचं पण केलं कॅमेरा नसतं.
Okay, no problem. So I hope my voice is properly audible to all. So maybe due to some technical problem, it is not audible to me from your side. But I hope my voice is properly audible to all. If it is not
Yes, sir.
audible, try to send your replies in the chat box. Okay. So we'll discuss through this chat box only. Okay. Okay. So with this particular problem, we have finished the SFD and BMD for the overhanging beam. So I have told one problem I will give for your exercise. Once the lecture is over, you just try to solve at your home and send the solutions to me. Okay. So, and already I have told what are the procedure we have followed for the simply supported beam. Same procedure we have to follow for the overhanging beam. No any step change, nothing is changed. It will be same. And always, if there is a simply supported beam, sometimes the statement will be given and sometimes figure is directly given. So if statement is given, you have to read that particular statement carefully and accordingly you have to draw the figure first and then you have to go for the further solution. But now in this particular online examination, such types of the big problems it will not be asked. But to understand all the MCQ based questions which will be asked in the examination, to understand all those concepts, to understand all those particular MCQ questions, we need to understand the basic procedure of SF calculation and BM calculation, because so many times I have told this is the point of contrast shear, this is the point of contraflexure, this is the point at which shear force is 0, this is the point at which bending moment 0, this is the point at which SF changes sign from positive to negative. So these are the some basic things which is very, very important for your MCQ examination. So purposefully, I have explained all these particular basic concepts while solving the numericals. So whenever we are solving the numericals, and I have told, so you just try to prepare your own problem. You take one beam, apply number of loads on it, and you just try solve it and check whether your answers are coming correct or not. So like that, you have to make the practice. Then and then only your answers becomes correct, or your concepts also becomes very strong and need not require to remind that concepts again and again. Okay, so with this SFD and BMD for the simply supported and overhanging beam we have finished, and now we'll move to the next type, that is SFD and BMD for the simply supported beam. So you just put the title SFD and BMD for the cantilever beam, not simply supported. SFD and BMD for the cantilever beam. So put the next title, next heading, SFD and BMD for cantilever beam. And now here one small change we have to make. So whatever the procedure we have followed for the simply supported and the cantilever, so somewhat same procedure we have to follow for the cantilever beam for SF calculation, but for BM calculation we need to change our sign conventions and somewhat we need to change our procedure. So put the title SFD and BMD for the cantilever beam. And what is the first requirement? What is the first procedure? For cantilever beam, SF calculation start from left side of the beam. SF calculation will start from left side of the beam. Same we have also followed for our simply supported and the overhanging beam. That is SF calculation we have started from the left side of the beam. Therefore, the forces which are moving in upward direction, that we have taken positive, and the forces which are moving in downward direction, that we have taken negative. Means the process of SF calculation for simply supported beam, for overhanging beam, and for cantilever beam, it is same. That is for all the three types of beam, SF calculation we are started from the left side. Therefore, upward जाणारे forces positive, downward जाणारे forces negative. So this is the first step, which is similar. But now if you look at to the next BM calculation, what I have written here, for cantilever beam, BM calculation will start from right side of the beam. In cantilever beam, for more and more simplification, हे कशासाठी प्रोसेस आपण इम्प्लिमेंट करतोय? फॉर मोर अँड मोर सिम्प्लिफिकेशन द बीएम कॅल्क्युलेशन वी हॅव टू स्टार्ट फ्रॉम राईट साइड ऑफ द बीम. आय एम टेलिंग ओनली बीएम कॅल्क्युलेशन. In simply supported and cantilever, sorry, in simply supported and the overhanging, SF calculation also we have started from the left side, and BM calculation also we have started from the left side. But in cantilever beam, only BM calculation we have to start from the right side, and as we have changed that position for clockwise movement, for clockwise movement and clockwise couple, we have to take it as a negative, and for anti-clockwise movement and anti-clockwise couple, we have to take it as a positive. बघा, सिम्पली सपोर्टेड मध्ये आणि ओव्हरहँगिंग मध्ये आपण लेफ्ट साइड पासून स्टार्ट केल्यामुळे क्लॉकवाइज मुवमेंटला आपण पॉझिटिव्ह म्हणत होतो आणि अँटी क्लॉकवाइज मुवमेंटला आपण निगेटिव्ह म्हणत होतो. But in cantilever beam, we have changed their procedure. Instead of doing the calculation from the left side, we are doing the calculation from the right side. मग राईट साइड पासून स्टार्ट केल्यामुळे त्याच्या क्लॉकवाइज मुवमेंट पण चेंज झाल्या आणि अँटी क्लॉकवाइज मुवमेंट पण चेंज झाल्या. मुवमेंट चेंज झाल्या म्हणजे काय झालं? त्याचे फक्त साइन कन्व्हेन्शन चेंज झालं. लेफ्ट साइड कडून स्टार्ट करत होतो म्हणून क्लॉकवाइजला पॉझिटिव्ह म्हणत होतो आणि अँटी क्लॉकवाइजला निगेटिव्ह म्हणत होतो. बट हिअर वी आर स्टार्टिंग फ्रॉम द लेफ्ट राईट साइड, म्हणजे लेफ्ट साइड वरून स्टार्ट करायच्या ऐवजी आपण काय करतोय? राईट साइड कडून स्टार्ट करतोय. म्हणूनच फॉर क्लॉकवाइज मुवमेंट वी हॅव टेकन निगेटिव्ह and for anti-clockwise movement we have taken positive. Only this much difference is there in the cantilever beam for the BM calculation. Getting? So for the simply supported, for overhanging and for cantilever beam, SF calculation we are starting from the left side. Therefore upward forces we have taken positive, downward forces we have taken negative. But for the cantilever beam, the BM calculation we are starting from the right side. BM calculation म्हणजे BM means bending movement, that is force into distance, म्हणजे it becomes movement. Okay, so as it is starting from the right side, clockwise ला आपण पॉझिटिव्ह म्हणण्याच्या ऐवजी आपण निगेटिव्ह म्हणतोय आणि अँटी क्लॉकवाइज ला आपण निगेटिव्ह म्हणण्याच्या ऐवजी काय म्हणतोय? पॉझिटिव्ह. So you just take this particular sign conventions in your notebook. So put the heading and take first one. For cantilever beam, SF calculation start from left side. Write down. For cantilever beam, SF calculation start from left side of the beam. SF calculation start from left side of the beam. Therefore below that, upward forces positive and downward forces negative. Make underline to start from left side. This sentence is very important. So upward forces positive, downward forces negative. Then next, for cantilever beam, BM calculation start from right side of the beam, and make double underline. Start from right side of beam. BM calculation start from right side of beam. Make double underline to this sentence, start from right side of the beam, and below that write down clockwise movement and clockwise couples. Clockwise movements and clockwise couples will be negative, and anti-clockwise movements and anti-clockwise couples will be positive. And त्याच्या खाली साइन कन्व्हेन्शन पण लिहा. Draw one movement like clockwise movement like this. This is clockwise movement and त्याच्या सेंटरला निगेटिव्ह करा, and then anti-clockwise movement त्याच्या सेंटरला पॉझिटिव्ह करा. So only this much change we have to make in the cantilever beam. Otherwise, further things are same. And these sign conventions we have to implement to draw the Sfd and Bmd for the cantilever beam. So why we have started this particular BM calculation from the right side? Because if we will start it from the right side, your calculation and your simplification becomes very, very simple. ते जर तुम्ही लेफ्ट साइड पासून स्टार्ट केलं तर समटाइम्स देयर इज अ पॉसिबिलिटी ऑफ कन्फ्युजन अँड देयर इज अ पॉसिबिलिटी ऑफ कन्फ्युजन इन द कॅल्क्युलेशन ऑल्सो. So instead of starting it is from the left side, for more and more simplification and for more and more simple understanding, purposefully we are starting from the right side, and right side पासून स्टार्ट केल्यामुळे त्याचे साइन कन्व्हेन्शन काय झाले चेंज झाले. If it is starting from the left side, again clockwise movement we are taking positive, anti-clockwise movement we are taking negative. But here we have changed their position. That's why that sign convention becomes exactly opposite. So and that these sign conventions we have to implement for your further SF and BM calculation for the cantilever beam only. Okay, I hope you have taken this particular sign conventions in your notebook. Yes, have taken it in your notebook.
Yes, sir.
Okay. Take it. It is very important. These sign conventions are very important. You have to keep in your mind because we have to use it during SF calculation and BM calculation, and accordingly we have to draw the SFD and BMD. Okay. So these are the sign conventions, and now we'll solve the problems based on the SFD and BMD for the cantilever beam. So write down, draw SFD and BMD for cantilever beam. Draw SFD and BMD for cantilever beam shown in figure below. Draw SFD and BMD for cantilever beam shown in figure below. So that loading diagram is given to you. So I will draw the figure here, and accordingly you take it in your notebook. So cantilever beam means their one end is fixed, another end is free. So like that you have to draw the structure of the beam. So one end is fixed, another end is free, and it is subjected to the point loads. So how it is subjected to the point loads? Let us see. This is one point load. This is second point load. This is third point load. And this is fourth point load. So the fixed side will be considered as point A, then B, C, D, and E. So the point load applied at point B, it is equal to 400 kilonewton. Then next 300 kilonewton. Then next 800 kilonewton. So point load at point D is 800 kilonewton, and point load at point E is equal to 500 kilonewton. Okay, so this is the loading diagram. Below that, the distances are also given. So the first one 0.5 meter, then second also 0.5, then 0.5 meter and 0.5 meter. So this is the loading diagram. So what that particular loading diagram indicates, that is one cantilever beam is there, which one end is fixed, that is point A is fixed, and one end is free, that is point E is free. And this cantilever beam is subjected to the total 4 point loads. One load is applied at point B, then at point C, then at point D, and one more point load is applied at the free end of the beam, that is at point E. And we have to draw their SFD and BMD. So this is the loading diagram in front of you. So here you have to take this particular projection lines as it is below the loading diagram. So these are the projections. So here need not required to draw the loading diagram once again, because the beam is subjected to only point loads. If it is subjected to the UDL, so we need to convert that UDL into point load, and again that point load we have to represent by the dotted lines. So means once again we have to draw the loading diagram. But here the beam is subjected to only point loads, so need not required to go or to draw the loading diagram once again. So directly we can go for the reaction calculation. Now before moving to the reaction calculation, tell me at point A, the beam is fixed. At point A, the beam is fixed, and already we have discussed in the types of supports, that is hinged support, roller support, and one more fixed support. So here in this particular beam, the fixed support is provided at point A. So how many reactions are present at point A? How many reactions are present at point A? Okay, 3. One answer I got, 3. What about others? How many reactions are present at point A? One answer I got, 3. So what about others? You can check the types of supports, the table I have given you. Number of reactions present at point A or number of reactions present at the fixed support. Number of reactions present at the fixed support. So total number of reactions at the fixed support. So only one. So what about others? What will be your answer? You can send your answers in the chat box because your voice is not audible to me. Total number of reactions at the fixed support. Yes, 3. Second answer also I got. Okay. So at point A, always there is a 3 reactions. I have told while discussing the supports. So basically 3 supports are there: roller support, hinged support, and the fixed support. So for the roller support, there is only one reaction, that is vertical, and we are considering that vertical reaction for our calculation. Then there is a hinged support, which is also called as a pinned support. For the hinged support, it is having the 2 reactions, that is one is vertical, another is horizontal. We are taking only vertical reaction for the calculation. We are not considering any horizontal force. We are not considering any horizontal reaction for the calculation. And then third support is the fixed support. Fixed support means here, which is provided in the cantilever beam, that is at point A. And at this particular point A, total 3 reactions are present. जसं रोलर ला एक रिएक्शन असते, जसं हिंज्ड सपोर्ट ला एक रिएक्शन असते, तसं फिक्स्ड सपोर्ट ला बेसिकली देयर आर 3 reactions. Out of that, one is vertical, second one is horizontal. म्हणजे रिएक्शन RA झाली, ही पण रिएक्शन RA झाली, म्हणजे रिएक्शन RA is present in vertical direction also, reaction RA is present in horizontal direction also, and in addition to that, this point A is also subjected to one movement. म्हणजे ही झाली तुमची तिसरी रिएक्शन, that is MA. Like this, 3 reactions are present at point A. Please keep in mind. So, in case of a cantilever beam, always there is a one fixed support, because there is a definition for the cantilever beam. The beam whose one end is fixed and another end is free. So, wherever the one end is fixed, that means at this particular end points, total 3 reactions are present. Out of that, one is vertical reaction, another is horizontal reaction, and third one is movement about point A, that is MA. But during our further calculation, we are considering only vertical reactions. Horizontal reaction आपण कुठल्याच कॅल्क्युलेशन मध्ये म्हणजे समेशन ऑफ रिएक्शन कॅल्क्युलेशन मध्ये पण कन्सिडर करत नाही आणि एसएफ कॅल्क्युलेशन मध्ये पण कन्सिडर करत नाही. कारण because in reaction calculation we are taking only vertical forces. What is the meaning of summation of FV? Summation of FV means summation of vertical forces is equal to 0. So horizontal force we are not considering in the calculation. That's why in case of a cantilever beam, at this particular fixed support, we are considering only vertical forces in our calculation. म्हणजे इथं तुमचा सपोर्ट दाखवला नाही म्हणजे ह्याचा अर्थ असा नाही की इथं रिएक्शन नाही. ज्या ज्या ठिकाणी असा फिक्स्ड सपोर्ट दिलेला असतो त्या त्या ठिकाणी तुमची 101% एक हॉरिझॉन्टल रिएक्शन असते, एक व्हर्टिकल रिएक्शन असते आणि एक मूवमेंट पण असतो. पण कॅल्क्युलेशन मध्ये आपण पुढं फक्त व्हर्टिकल रिएक्शन आणि ही मूवमेंटच पुढं कन्सिडर करणार आहे. वी आर नॉट कन्सिडरिंग एनी हॉरिझॉन्टल रिएक्शन. म्हणजे तर रिएक्शन दाखवले नाही म्हणजे याचा अर्थ असा नाही की ह्या ठिकाणी रिएक्शन नाही. दॅट So here also once again we have to apply the same things. Summation of vertical forces is equal to 0. Whether my voice is audible to all? Anybody can you unmute?
Yes, sir. Yes, sir.
Now it is audible to me. Okay, so now put the first, because again there is electricity problem, so I hope my voice my screen is not visible to you, but still we go for the reaction calculation. We have to follow the same procedure. So put the first title reaction calculation. In that, upward forces positive, downward forces negative. Draw this particular sign conventions in front of that heading. Upward forces positive, downward forces negative. Now tell me, how many total number of forces are present, vertical forces, on the cantilever beam, including reaction and including point loads?
5.
5 forces. How it is? Because the beam is subjected to the 4 point loads. 1 point load at point B, then at point C, at point D, and at point E. These are the original point loads. And at point A, just now we have discussed, त्या ठिकाणी तुम्हाला रिएक्शन दाखवली नाही म्हणजे याचा अर्थ असा नाही की त्या ठिकाणी रिएक्शन नाही. But always at the fixed support there is a total 3 reactions. One is vertical, another is horizontal, and one more is movement. Therefore, you have to represent that reaction RA at point A also. त्यामुळे त्या point A ला असा एक vertical बाण काढायचा आणि त्या ठिकाणी you have to write down RA. So total 5 forces are present. So you just put the heading. Summation of vertical forces is equal to 0. Then upward forces positive, downward forces negative. So start from the left side. RA, it is moving in positive direction. Therefore, plus RA, minus 400, minus 300, then minus 800, and minus 500. Why all point loads are minus? Because they are moving in the downward direction, means we have to take their effect as a negative. So reaction RA is equal to, what will be your value? Tell me.
2000.
2000 kilonewton, correct. So reaction RA is equal to 1000. कारण ह्या सगळ्या व्हॅल्यू तुमच्या निगेटिव्ह होत्या. ते निगेटिव्ह व्हॅल्यू जर तुम्ही सगळ्या राईट साइडला घेतल्या तर इट बिकम्स पॉझिटिव्ह. मीन्स RA is equal to 400 plus 300 plus 800 plus 500, and that addition you will get as a 2000 kilonewton. Okay, so this is the reaction calculation. Now next heading, SF calculation. Next heading, SF calculation. In bracket, write down, start from left side. Next heading, SF calculation. In bracket, start from left side. In front of that, upward force is positive, downward force is negative. So try to write down the sign conventions for each and every heading. कारण आपल्याला समजतंय की आपण इथं पॉझिटिव्ह घेतले का निगेटिव्ह घेतले. So SF at or SF calculation start from the left side. Upward force is positive, downward force is negative. Can anybody can you unmute?
Yes, sir.
Yes, sir.
Yes, sir.
Yes. Yeah, now it is audible. Just I will share the screen. So due to that electricity problem again and again. Just wait. Okay, just wait. I will draw the figure once again. So this is point A, B, C, D, and E. So here at point A, there is a reaction, means you have to represent RA. Okay. So this is of 400 kilonewton. This is of 300 kilonewton. This is of 800 kilonewton. And this is of 500 kilonewton. And this distance is as 0.5 meter. This is 0.5, this is 0.5 meter, and this is 0.5 meter. This is this. Okay. You have to take their projection lines. So first one reaction calculation we have done, that is summation of vertical force is equal to 0, means RA minus 400 minus 300 minus 800 minus 500 is equal to 0. Therefore, RA you will get 2000 kilonewton. Now next, SF calculation. SF calculation, in that upward force is positive, downward force is negative, and we have to start it from left side. Now see, shear force at point A. We have to start your SF calculation from the left side. Shear force at point A. So what we have to do here? SF at A. What will be the condition?
Without load.
Without load, because at point A there is a reaction, and if the beam is subjected to the reaction, or if beam is subjected to the point load, we need to take the without load and with load condition. So without load it becomes equal to 0 kilonewton. Then SF at A with load. With load means what is the value of RA? it is moving in the positive
2000.
2000 kilonewton. As the reaction R is moving upward, therefore we have to take positive or plus 2000 kilonewton. Then next point, SF at B. Again at point B there is a point load, so we need to take the without load. So without load means without considering the point load of the B, number of forces present at the left side, how much?
1.
1.
1. ती म्हणजे कुठल्याही रिएक्शन, write down as it is 2000 kilonewton. Then next, SF at B with load is 2000 minus
400.
400. With load means त्याच्या लेफ्ट साइडचे पण फोर्सेस आणि त्या पॉइंटचा पण लोड, म्हणजे this is the without load condition. Okay, and this 400 is moving in downward, therefore negative, so it becomes 1600 kilonewton. Then next, SF at C, again there is a without load. Tell me number of forces present at the left side of the point C in without load condition. 2. म्हणजे 2000 minus 400 is equal to 1600. Okay, then SF at C with load, म्हणजे लेफ्ट साइडचे सगळे फोर्सेस 2000 minus 400 with load means त्या पॉइंट वर किती लोड आहे? 300. So minus 300. What will be this answer?
1300.
1300 kilometer. Then next, SF at D without load. Total number of forces at the left side without load condition
3.
3.
3. Tell me one by one. 200 minus
Minus 400 minus 300.
minus 300 is equal to 1300 kilonewton. हे कॅल्क्युलेशन नाही लिहिलं तर चालतं, डायरेक्ट जर तुम्हाला अंडरस्टँडिंग होत असेल तर डायरेक्ट 1300 व्हॅल्यू जरी लिहिली तरी चालते. जस्ट आय एम रिप्रेझेंटिंग और रायटिंग फॉर युअर अंडरस्टँडिंग, दॅट इज नंबर ऑफ फोर्सेस प्रेझेंट ॲट द लेफ्ट साइड. सो SF at D with load, म्हणजे विदाउट लोडचं आपल्याला ऑलरेडी 1300 माहित आहे, and with load means minus 800 is equal to 500 kilonewton. And SF at E without load, म्हणजे परत 2000 minus 400 minus 300 minus 800 is equal to 500 kilonewton. And next, SF at E with load is equal to 500 minus 500 is equal to 0. So here also our conditions are satisfied, that is the start of the SF calculation and end of the SF calculation, it is coming equal to 0, means whatever the middle calculation we have done for remaining all the points, it is 100% correct. So now immediately you have to go for your SF diagram. Now if you look at all the values, the shear force value at each and every point, all the values are positive, that is SF at point A 0, then at point A without load 2000, at point B again values are 0, at point C again values are positive, at point D again values are positive. That means your SF diagram will be in positive region. So point A, B, C, D and E. Tell me one by one. SF at point A without load 0. SF at point A with load
2000.
2000 kilonewton. SF at point B without load 2000. Same point will be continue 2000 kilonewton. SF at point B with load
1600.
कुठे येणार आहे सांगा, त्याच लाईनवर येणार आहे का पुढच्या लाईनवर येणार आहे?
त्याच लाईनवर खाली.
म्हणजे खालच्या बाजूला येतं. सो दिस इज 1600 kilonewton. SF at point C without load.
1600.
1600.
Then SF at point C with load.
1300.
1300.
त्याच लाईनवर खालच्या बाजूला 1300 kilonewton. SF at point D without load.
1300.
1300 kilonewton. परत SF at point E,
500.
sorry, at point D once again one more point load is there, that is 500. म्हणजे त्याच लाईनवर परत हा 500. and SF at point E
500.
500 kilonewton without load, and with load झाला तो
0.
Now here your loading diagram, it is subjected to only point loads. So if I am joining all the points, which lines I have to use? Which lines I have to use?
Straight line.
Vertical and horizontal.
Vertical and horizontal. बघा तुम्ही कुठला जरी पॉइंट तुम्ही जोडायचं म्हणलं तर त्या तुम्हाला ठिकाणी तुम्हाला कुठलीच इन्क्लाइन्ड लाईन मिळणार नाही. If we follow the proper procedure from A to B, B to C, C to D, D to E, if follow the proper procedure, you will get only verticals and the horizontal lines. त्यामुळे पहिल्यांदा 0 पासून 2000 कडे गेलो आपण. परत this is A to B, परत B वर 2 पॉइंट, it is drawn like that. परत B to C, again from C point there is a 2 points because without load and with load conditions are there. बघा जिथे जिथे without load and with load condition आपण घेतलेले आहेत त्याच पॉइंटला दोन आपल्याला पॉइंट मिळालेले आहेत due to without load and with load. Again from C to D, this is the horizontal line. Again from D there is a vertical line without load, and from D to E this is horizontal, and then this is 0. So this is your SFD. You will get SFD in positive region only. So here at any point there is no any SF change or SFD change from positive to negative. So here there is no any point of contrashear. And in case of a cantilever beam, very less chances are there where you will get the point of contrashear and the point of contraflexion. 90% problems are there where you will not get point of contrashear and point of contraflexion. Remaining 5 to 10% problems are there where there is a possibility of point of contrashear and point of contraflexion. But in cantilever beam, maximum times your SFD will be generated in positive region only, and your BMD will be generated in negative region only. 90% प्रॉब्लेम असे आहेत कॅन्टिलिव्हरचे की ज्यामध्ये तुमची एसएफ डायग्राम ही फक्त पॉझिटिव्ह रिजन मध्येच असेल आणि तुमची बेंडिंग मोमेंट डायग्राम ही नेगेटिव्ह रिजन मध्ये असेल. बट इफ यू सी युअर सिम्पली सपोर्टेड अँड ओव्हरहँगिंग बीम, सो मेनी टाइम्स SF is changes from positive to negative, negative to positive. Your BM is also changes from positive to negative and negative to positive. Maximum percent such type of problems are there. But in case of a cantilever, maximum times SFD will be in positive region and BMD will be in negative region. Okay, so now this is SF calculation. Then third, BM calculation, and in bracket write down this. Start from right side. So clockwise movement we need to take negative, and anti-clockwise movement we need to take positive. Now tell me, if I have to start the bending moment calculation from the right side of the beam, from which point we have to start the BM calculation?
E.
We have to start it from E. जसं आपण SF calculation लेफ्ट साइड पासून स्टार्ट केले म्हणजे लेफ्ट साइड आपला कुठला पॉइंट होता? पॉइंट A. But now for more simplification, for cantilever beam we need to start their BM calculation from the right side. त्यामुळे प्रत्येक BM calculation असं लिहायचं. BM calculation start from right side, clockwise movement negative, anti-clockwise movement positive. So first point, BM at E, what will be the value?
0.
0, because at the right side of the point E, जसं आपण लेफ्ट साइडचा आतापर्यंत विचार करत होतो, ह्या पॉइंटच्या लेफ्ट साइडला एवढे फोर्सेस आहेत, त्या पॉइंटच्या लेफ्ट साइडला एवढे फोर्सेस आहेत. बट नाव हियर वी हॅव स्टार्टेड द बीएम कॅल्क्युलेशन फ्रॉम द राईट साइड आणि ईच्या राईट साइडला एक पण फोर्स नाही. अँड दिस इज ऑल्सो एंड पॉइंट ऑफ द बीम. This is also end point of the beam. Therefore, Bm at E is equal to 0 kilonewton meter. Bm at D. Now tell me how many forces are present to the right side of the point D? कारण आपण right side पासून start करतो.
One.
Only one. Okay. And now this force is rotating clockwise or anti-clockwise?
Clockwise.
Clockwise.
Clockwise आपल्याला काय घ्यायचं तर निगेटिव्ह का पॉझिटिव्ह?
Negative.
Negative.
Therefore, minus 500 into 0.5. Tell me this answer.
Minus 250.
Minus 250 kilonewton meter. Then Bm at C. Right side
force
forces.
download होता ना.
No. Now this is not force now. Now we are resolving the force. डाउनवर्ड फोर्सेसचा इफेक्ट आपण एसएफ कॅल्क्युलेशन मध्ये कन्सिडर केलेलाच आहे ना. इन एसएफ कॅल्क्युलेशन वी हॅव टेकन इट डाउनवर्ड फोर्सेस निगेटिव्ह, अपवर्ड फोर्सेस पॉझिटिव्ह. बट नाव हियर वी आर रिझॉल्विंग द फोर्सेस. हा फोर्स आपण रिझॉल्व करतोय. रिझॉल्व करताना आपल्याला त्याला फोर्स इंटू मल्टिप्लाय बाय डिस्टन्स असतं. आपण इथं मुवमेंट घेतोय, त्यामुळे ह्या ठिकाणी फोर्सचा इफेक्ट आपण कसा कन्सिडर करणार? हा निगेटिव्ह मध्ये चालला म्हणून ह्याचा अर्थ असा नाही का तो निगेटिव्ह मध्ये. वी आर टेकिंग द मुवमेंट. आता डी ला करताना आपण हा ई चा फोर्स आपण डी ला रिझॉल्व केला, पण तो रिझॉल्व करताना क्लॉकवाइज मुवमेंट मध्ये जातोय का अँटी क्लॉकवाइज मुवमेंट मध्ये जातोय? दॅट वी हॅव टू चेक. अँड हियर इट इज मुव्हिंग इन क्लॉकवाइज. आणि क्लॉकवाइज आपण साइन कन्व्हेन्शन काय सांगितलंय? निगेटिव्ह. आणि अँटी क्लॉकवाइजला काय सांगितलंय? पॉझिटिव्ह. गेटिंग?
Yes, sir.
सो फोर्स जरी निगेटिव्ह मध्ये जात असेल तर इथं निगेटिव्ह फोर्सचा इफेक्ट आपण घेत नाही, कारण इथं आपण फोर्स कॅल्क्युलेट करत नाही. वी आर कॅल्क्युलेटिंग द बीएम. आणि बीएम म्हणजे काय असतं? फोर्स इंटू परपेंडिक्युलर डिस्टन्स. नाव हाऊ मेनी फोर्सेस आर प्रेझेंट ऍट द लेफ्ट साइड ऑफ द पॉइंट सी?
2.
2. मग पहिल्यांदा घ्या सगळ्यात एंडचा मायनस
500 into 0.5.
मायनस 500
Into
इंटू 1. सी
1.
आणि मधलं डिस्टन्स 1 आहे. 1 and minus 800 into
0.5.
0.5.
tell me this answer.
Minus 900.
900.
Minus 900 kilonewton meter. The next point, Bm at B. Number of forces 3. Correct? मग पहिल्यांदा घ्या सगळ्यात एंडचा minus 500 into 1.5 minus 800 into 1 and minus 300 into
0.5.
0.5. What will be this answer?
Minus 1700.
Minus 1700 kilonewton meter. Bm at A, whether it is coming equal to 0 or not. जरी हा बीमचा एंड पॉइंट असेल तरी ह्या पॉइंटला तुमचा बेंडिंग मोमेंट 0 असेल का?
No, sir.
No.
Why? Why?
It is fixed.
इट इज फिक्स्ड. आणि फिक्स्डला आपण काय सांगितलंय? देर आर टोटल 3 रिएक्शन्स. वन इज व्हर्टिकल रिएक्शन RA, अनदर इज हॉरिझॉन्टल रिएक्शन, आणि तिसरा म्हणजे ह्या पॉइंटला एक मुवमेंट पण असतो ज्याला आपण MA म्हणतो. मग इथं मुवमेंट असतो म्हणजे ह्या मुवमेंटला काय तर व्हॅल्यू असणार आहे. हा मुवमेंट इट इज नॉट इक्वल टू 0. जरी हा पॉइंट तुमचा एंड पॉइंट असेल तरी पण कॅन्टिलिव्हर बीम मध्ये फिक्स्ड सपोर्टला तुमचा बेंडिंग मोमेंट 0 होत नाही. बिकॉज ऍट द फिक्स्ड सपोर्ट देर इज अ टोटल 3 रिएक्शन्स. त्याच्यामधली एक हॉरिझॉन्टल आहे, एक व्हर्टिकल आहे, आणि तिसरी रिएक्शन मध्ये त्याच पॉइंटला एक मुवमेंट असतो, अँड दॅट मुवमेंट इज नॉट इक्वल टू 0. And up till now for the simply supported and the overhanging beam we have done calculation also at the end points. and that calculation is also coming equal to 0. But now here, if you do the calculation, bending moment at point A च्या right side ला किती forces आहेत? 1, 2, 3 and 4. Tell me one by one. Minus
500.
minus 500
into 2.
just wait. Minus 500 into 2 minus 800 into
1.5.
minus 300 into
1.
and minus 400 into
0.5.
मग हे आन्सर तुमचं 0 येते का बघा.
No.
Whether it is coming equal to 0, then what is the value of bending moment at point A?
Minus
Minus 2,700.
700.
Minus 2,700 kilonewton meter, and it is not also coming equal to 0 because we are having the definition of the fixed support, that is it is having total 3 reactions: vertical, horizontal and movement. मग त्या पॉइंटला जर त्या ठिकाणी रिएक्शन मध्ये मूवमेंट दाखवत असेल तर that value will not becomes equal to 0. So please keep in mind, in case of a cantilever beam at free end, bending moment is equal to 0, but at fixed end bending moment not coming equal to 0 as it is subjected to one moment. Therefore at the fixed point also you will get the some value as a moment, and that we have to calculate by considering all the forces which are present at the right side of the fixed support. But if you think about the simply supported and overhanging, त्या दोन्ही बीम मध्ये एंड पॉइंटला तुमचा बेंडिंग मोमेंट कायम it is equal to 0. Okay, so now you have to draw the figure. Now if you look at all the values of Bm, तुम्ही सगळ्याच्या Bm जर व्हॅल्यू बघितल्या तर all values are negative. Therefore your BMD will be in a negative region only. Once again, this is the horizontal line. So this is point A, B, C, D and E. So Bm at point E is equal to 0. Bending moment at point D, how much?
Minus
Minus 200.
250.
Minus 250 kilonewton meter. Only represent the point
200.
first. How much?
200.
250.
250, correct. Minus 500 into 0.5. Just 250. Then next, bending moment at point C.
Minus 900.
Minus 900.
Minus 900 kilonewton meter. Then bending moment at point B.
1700.
1700 kilonewton meter. And last bending moment at point A.
Minus 2700.
2,700.
Kilonewton meter. Then how to draw all the points?
Inclined line.
Inclined line. जर ह्या ठिकाणी कुठं जर UDL असला असता तर आपण तो कशाने ड्रॉ केला असता BM मध्ये?
Parabolic.
Parabolic curve. But here from all the points A to B, B to C, C to D and D to E, there is no any UDL is present. Therefore we need to represent all the joint or all the points by using the inclined line. So here D to E inclined line, then C to D, again there is an inclined line, then B to C, again there is an inclined line, then A to B, again there is an inclined line, and you have to join this particular point also like this, and this is your negative region, that is BMD. So this is your the problem based on SFD and BMD for the cantilever beam. So only small change we have made, that is BM calculation we have started from the right side, and due to this the sign conventions will get changed, that is clockwise movement negative, anti-clockwise movements positive. So this is one sample problem for the cantilever beam, and when it is subjected to the point load, how to go for the solution. So same procedure we have to follow for remaining all the cantilever beams when it is subjected to the point load, UDL, couple, or any type of another type of load. Same procedure we have to follow. But SF calculation we have to start from the left side, and BM calculation we have to start from the right side. Yes, understood?
Yes,
Yes,
sir.
yes, sir.
Yes. Everyone have understood this particular procedure for the cantilever beam, how to draw SFD and BMD, and how to go for the SF calculation and BM calculation.
Yes, sir.
समजलंय का सगळ्यांना?
Yes, sir.
So you can give your replies in the chat box, all of you. Then I can understand everyone has understood. So process is very simple as compared to the simply supported and overhanging. The cantilever beam solution is very simple, because here there is no any chance of X calculation, because your SFD will be in positive region and BMD will be in negative region only. Therefore, there is no any chance to change your SF and BM from positive to negative. जर ते positive to negative कडून जर changes होत नसेल, तर there is no any chance of X distance calculation. Only we have to go for the reaction calculation, SF calculation, and BM calculation. But understand the difference between simply supported overhanging and cantilever beam, and how at fixed support bending moment is not coming equal to 0, because it is subjected to the movement also, and movement त्या ठिकाणी कधी 0 येत नाही. That's why at point A also your bending moment value is coming, but at the free end bending moment value is equal to 0. Okay, so I hope you have understood. Still again you are having some 2 to 3 variety of problems based on this cantilever beam that we will take in the next lecture. With this particular numerical, today we will stop here. Remaining problems that we will take in the next lecture. Okay, thank you.